Hi everyone, this is 10.1's post-test on Pythagorean theorem. The Pythagorean theorem is here. It is, I'm sure, hopefully we remember this, but in a right triangle, if the two smaller sides of the right triangle are labeled A and B, and the hypotenuse is C, then the length of the two smaller legs, when you square them and add them, is equal to the square of the hypotenuse. So a squared plus b squared equals c squared. Again, in a right triangle. So a lot of these questions are going to have having to deal with right triangles, like this first one. Find the unknown length in the right triangle. Use a calculator to find square roots. So the key with most questions in this post test is just determining which side is the hypotenuse, because that specifically has to go here in the theorem. Okay, A and B are interchangeable. So we have to identify where the hypotenuse of the right triangle is, and the hypotenuse of a right triangle is always opposite the right angle. So the right angle is labeled here. The side opposite that, in this case, is the 13. So if I use Pythagorean theorem here, okay, I know the 12 is either A or B. Okay, 12 is not the hypotenuse, but 13 is. So it doesn't matter where the 12 goes. It can go in either A or B, but C has to be the 13 here. Okay, so I'm just going to say A squared, I will say it's B, plus the 12 squared equals 13 squared. Okay, and then we just have to solve this for A. So we can find what 12 squared is. 12 squared is 144. 13 squared is 169. So we have A squared plus 144 equals 169. To solve for A, we have to subtract this 144 on both sides. So we get A squared is equal to 169 minus 144. That is 25. So we get A squared is 25, but we want to know what A is because that's the side of this triangle. So to find A, we have to undo this square by square rooting both sides. So A, the square root of 25, is 5. So the length of that triangle, this side of the triangle, is 5. Okay, in the given figure, what is the value of x? So I have a circle where it looks like O is the center. I have a radius here of x. I have a radius here of x. Okay, they're both x because they're both our radii of the circle. But I also have this right triangle drawn. And in this right triangle, I have some lengths. I know that this side of the triangle is 36 inches. I know this side of the triangle is x. And I know this side of the triangle is a combination of x and this 24. Okay, and that's what I'm going to use to set up my theorem. So again, I want to identify where my hypotenuse is. So here's my 90-degree angle, my right angle. Opposite that is this side of the triangle with the x and with my 24. Okay, so the x plus the 24 is my c. Okay, so I have to add them and square it to get the c squared. Okay, again, the x plus the 24 is that side. And then the a and the b part of the theorem, I have x squared or a squared, and then 36 squared could be my b squared. Okay, and now I just need to simplify this equation. So on the left here, I have x squared plus, and 36 squared is 1296 equals, now here I have x plus 24 all being squared. Okay, remember when you square something, that means you're multiplying something by itself twice. So this really is x plus 24 times x plus 24. And thinking back to probably Algebra 1, this is a double distribution question now. Okay, the x has to multiply to the x, which is x squared. The x also has to multiply to that 24, which is a positive 24x. Then, so we just distributed this x, then we have to distribute this 24. So the 24 has to distribute to x, so that's another positive 24x, and the 24 needs to distribute to that 24, okay, which is 24 squared, which is 576. So this is a double distribution. Okay, it's not quite simplified yet because these are like terms, 24x plus 24x. So this multiplication, this x plus 24 squared, simplifies to x squared plus 48x plus 576. And that's equal to my a squared plus the b squared. Okay, so now I can solve this equation for x. So first I'm going to handle the x squares. Okay, I'm going to subtract the x squared here, but if I subtract x squared here, I have to subtract it here, and lucky for us, the x squares will cancel each other out, so we don't have to deal with them at all. So now we just have 1296 equals 48x plus 576. Again, we want to solve this for x, so I'm going to subtract 576 on both sides. So I have 1296 minus 576, and that's 720, equals 48x. And then to solve for x, okay, I did run out of room, but to solve for x here, we're going to divide both sides by 48 to get x alone. So my answer is going to be 720 divided by that 48, and I get x to be 15. And it's asking for what the value of x is, so x for me is 15. Okay, this next question is just asking to find the square root of 3,000. So you can just go right into your calculator here. Again, your phone calculator might do something similar. Whenever I square root something, I have to type the number in first, and I believe your phone calculator will be the same. So I'm typing in 3,000, and then the square root button I had to hit second, and then this is the square root button, and then it will take the square root of the 3,000. Okay, it does say round to the nearest thousandths. So I have 54.7722. Okay, I wrote 4 numbers because the thousandths place, this is the tenths, hundredths, thousandths, is the third digit after the decimal place. So we really have to look at the fourth to determine if this third number stays the same or rounds up. So because this is a 2, this 2 is going to stay exactly the same. So my answer will be 54.772, rounded to the nearest thousandth. 54.772. Okay, find the unknown side of the right triangle. Use a calculator to find the square root. So again, we just have a diagram where we have 2 sides of the triangle. It's asking us to find the third side of that right triangle. Again, we're going to identify where the hypotenuse is. Again, here's my right angle. So the opposite side across from it is this length, which is unknown. So in this case, I don't know what C is. So I know what A and B is. So I have 15 squared plus 20 squared equals my C squared that I don't know. 15 squared is 225. 20 squared is 400. So I have 225 plus 400 equals C squared. 225 plus 400 is 625 equals C squared. And then to solve for C, we can square root. So C is going to be the square root of 625. And the square root of 625 is 25. So 25 is the hypotenuse there. Next question, use Pythagorean theorem to find the missing length. So very similar again. Okay, and this time it doesn't say where the right angle is. It does say it's a right triangle. So in this case we can assume, okay, the right angle is here. So across from that 90-degree angle is the hypotenuse. So in this case the hypotenuse is this 29. So that is my C squared. So 29 squared is my C. And then I can substitute the rest, A squared plus 19 squared. And in this case, we're just trying to find A. So simplifying here now, 19 squared is 361. 29 squared is 841. I'm putting that A squared here. So I have A squared plus 361 equals 841. Again, I need to solve this for A. So I'm going to subtract the 361 on both sides. So 841 minus 361 is 480. So we get 480 equals A squared. To solve for A, I'm going to square root both sides. So A is going to be equal to the square root of 480. So I have 480 already typed in. Going to second, then the square root button. So this is not a perfect square. I got a decimal. And it says to round to 1 decimal place as needed. So I have 21.90. So 1 decimal place as needed. This will just be 21.9. Okay, if m is an odd positive integer greater than 1, then m squared minus 1 divided by 2, m squared plus 1 divided by 2 is a Pythagorean triple. Use this to find the Pythagorean triple generated when m equals 11. So this is very wordy, but all it's saying is if m is 11, what are the three numbers going to be? So we just have to substitute 11 into these three things. Okay, well first, if m is 11, then this m is 11. So I know my first number is going to be 11. But now I'm just going to take that 11 and find the second number, which is m squared minus 1 divided by 2. I'm just going to substitute my 11 in. So 11 squared minus 1 divided by 2. Well, 11 squared is 121 minus 1 divided by 2. So 121 minus 1 is 120. 120 divided by 2 is 60. So the next number would be 60. And then the m squared plus 1 divided by 2. So m squared plus 1 divided by 2. So that would be 11 squared plus 1 divided by 2. Again, 11 squared is 121 plus 1 divided by 2. This is 122 divided by 2, which will be 61. So I have 11, 60, and 61. It does say to use ascending order, so that just means smallest to biggest, which it is written. So 11, 60, 61 is my Pythagorean triple. A rectangular garden bed measures 12 feet by 5 feet. Okay, so I'm just going to start drawing this. I know it's a rectangular garden. So here's my rectangle, 12 feet by 5 feet. So here's 12, here's 5. A water faucet is located at one corner of the garden bed. So I'm going to have a water faucet. So I'm just going to call it F for water faucet in the corner. A hose will be connected to the water faucet. The hose must be long enough to reach the opposite corner of the garden bed when stretched straight. find the required length of the hose. So the hose is connecting here to the corner and has to reach the opposite corner when stretched straight. So in other words, this is creating a right triangle where it's asking to find the length of the diagonal here. Okay, so again, if this is 5 here, this is also going to be 5. So it creates this right triangle. For this is 12, this is 5, and it's asking me to find that length. So again, Pythagorean theorem. We have to identify which side of this triangle is the hypotenuse. So my right angle is here. Opposite that right angle is my x. So it's asking to find the hypotenuse here. Okay, so my a squared, 5 squared, plus b squared equals c squared. Okay, or x squared. 5 squared is 25. 12 squared is 144. 25 plus 144 is 169 equals c squared. To solve for c, I'm going to square root both sides, and the square root of 169 is 13. So the length of this hose would be 13 feet. Okay, we have a multiple choice question here. Determine whether a tangent is shown in the diagram. Explain. Then we have 2 yeses and 2 nos. Yeses because we have a perpendicular segment to the radius, okay, or is not perpendicular to the radius at its endpoint. Okay, so to be this tangent, we need this perpendicular to the radius. Okay, the radius of the circle is here, and we need something that's perpendicular to it. So in other words, this question is just asking, is this right here a right angle? Okay, if we look at what's given to us, we have a triangle. So it's basically asking, is this a right triangle? So we're going to see if Pythagorean theorem works because we can use its converse, where if Pythagorean theorem is true, then it means it's a right triangle. So again, I need to see if this angle right here is the right angle, which means my hypotenuse is going to be 6.5. Okay, so I'm going to use that as my C, and 6 and 2.5 as A and B. So I have 2.5 squared plus 6 squared, and I'm going to put a question mark here, if that is equal to the hypotenuse squared. So if this is true, then this makes a right angle. So this would be a right triangle, and then we'll determine the answer here. So let's see. 2.5 squared is 6.25. 6 squared is 36. And 6.5 squared is 42.25. So I'm going to add these up and see if I get 42.25. So 6.25 plus 36 is 42.25. So this ended up being a true equation. It worked, which means Pythagorean theorem worked, which means that this is a right angle. This made a right triangle. So that means we do have a tangent because we have something that's perpendicular. So it's going to be one of the yeses. So A says yes because the segment that measures 6.5, so that's this, is perpendicular to the radius at its endpoint. So it's saying this 6.5 is perpendicular to the radius here. It's saying this angle is 90 degrees, which it is not. So it is not A. But C says yes because the segment that measures 6 is perpendicular to the radius at its endpoint. So this is where it's perpendicular. This is where the right angle is. So for me, my answer is C. Okay, a soccer field is 20 yards wide and 30 yards long. So we have 30 yards and 20 yards. If a person walks across the field along the diagonal instead of walking the length and width of the field, how much shorter is the distance? Okay, so we have a couple things here. One, we need to figure out what the distance of the diagonal is. And two, we have to figure out how much shorter that distance is than if you were to walk around the length and the width. Okay, and that's actually going to be the answer. So the first thing I'm going to do is I'm going to draw my right triangle. Okay, that was a bad right triangle. Okay, where it's telling me that this is 30 and this is 20. And I want to find the diagonal, okay, which would be the hypotenuse. So I'm going to find my hypotenuse here. So I have 30 squared plus 20 squared equals c squared. Okay, 30 squared is 900. 20 squared is 400. So we get 1300 equals c squared, which means c is going to be the square root, because I'm going to have to square root both these sides. So c is going to be the square root of 1300. Now, this is not a whole number. It is a decimal, and I do not want to round this number yet. Okay, I'm going to write it down rounded, but I'm going to end up keeping it in my calculator. Okay, 0.05, and there's another 5. So this question's asking how much shorter is that distance than if you were to walk around the border of the field. So if this person were to walk this distance and this distance, how far would that person walk? Well, that's 30 yards and 20 yards, so that person would be walking 50 yards, okay, adding those two together. The diagonal is only about 36 yards, and I want to know the difference, okay, how much shorter that is. So I'm going to take this number stored in my calculator and subtract the other distance that they would walk if they went around, which is the 30 and the 20, which is that 50 yards. So I'm subtracting it by 50. Now, you will get a negative just because of the order in which we did it, but the answer here is positive. Okay, and this is the exact number, the exact answer, but now we're going to round it to the nearest thousandth. So I have 13.94448. Okay, thousandths is the third number after the decimal point. So it's my second 4. So I'm really looking at the number next to it to determine if this 4 stays a 4 or rounds up to 5. But because that's a 4, it's going to stay, it's not going to round up. So this will be 13.944. Okay, next, find the unknown length in the right triangle. So again, just using Pythagorean theorem. Again, here's the right angle. Across from that is the hypotenuse. So in this question, I don't know the hypotenuse. So I know A and B. So I have 24 squared plus 18 squared equals c squared, the hypotenuse. 24 squared is 576. 18 squared is 324. Add those up. 324 plus 576 is 900. To solve for c, we're going to have to square root both sides. And the square root of 900, okay, is 30. You can always double check in the calculator. Square root 900 is 30. So the unknown length is my hypotenuse, and it will be 30 inches. Okay, and last question. Just as says to find the square root. Okay, the square root of 8, which is not a perfect square. So we're just going to put that in the calculator. So I'm typing in 8, hitting the square root button. I get this long decimal. I have 2.82842. But it round to the nearest thousandths. So again, that's the third number after the decimal point. So I'm really looking at the fourth number, which is a 4, which tells me my 8 is going to stay at an 8. So rounded 2.828. And that should be the last one. Okay, so that was 10.1, again, Pythagorean theorem. And it will be due at the end of the week on Friday.